We're grouping for our final presentation our client's edible arrangements, and we are going to help them build the largest fruit display ever. Our client's edible arrangements, and they were established in 1999. Edible arrangements produces gifts in baskets made with fresh fruit and gourmet chocolate. And better to suit their client, they use festive shapes, sizes, and a different assortment of fruits. Edible arrangement is available for in-store pickup and at-home delivery for small packages, but is always innovating and looking to expand their business. This holiday season, Edible Arrangements has been asked to build the largest display for New Year's Eve in honor of their increasing popularity across the United States.
In order to provide for this New Year's Eve celebration in New York, Edible Arrangements wants to build the world's largest fruit tower display, and in participating in this event, they will hopefully expand their company and become the #1 recommended fruit display company for gifts for holidays and other celebrations. In order to achieve this goal, they want to figure out exactly how tall they can build a display. They want this display to be as large as possible in order to draw the most attention. And they want us to test not only the visual appeal, but also the stability of the tower, as they don't want to end up on the front page of the New York Times with a headline such as "Great Start to 2019" as fruit display falls over and covers the entire Times Square. Along with size and stability, they want to test taste, so that way they can get the best fruit arrangement that will allow specific fruit flavors to complement flavors of the other fruits in the display. They want the best results so they can have positive publicity.
So, obviously the materials that we're going to be looking at for edible arrangements are fruits. And there are a lot of different kinds of fruits, but the specific types of fruit that we'll be looking at for edible arrangements are apples, bananas, strawberries, grapes, cantaloupe, and pineapple, and kiwi. And even though there are so many different kinds, so many different tastes, so many textures of fruit, there are some things that all fruits have in common. Now, all fruits are actually part of a plant, a tree, called an angiosperm. And the role that they play as part of this plant is that they distribute the plant's seeds. So what a fruit actually is it contains the seeds, and the seeds are in this kind of sweet or sour outer fleshy packaging. And animals will tend to eat this fruit for nutrition or because it tastes good, and then when they eat it, later when they excrete it, that distributes the seeds throughout the environment. And since this mechanism works so well for spreading the plant to different places and as a way for it to grow and distribute its seeds, fruits tend to taste really good, and a lot of people really enjoy eating fruit. So even though individual edible arrangements businesses all kind of have an established fruit provider that they always use, for this display, since it's for people coming from all around the nation, the company wants to consider every potential possibility. So they're going to be considering local sources, they're going to be considering outside sources, they're going to be considering the sources that all of the individual businesses use. They're going to be really considering their every option. So we're going to be looking at the different types, providers of fruit, and seeing which one is the best. And the function that the fruit will be fulfilling is to be twofold. The first function of the fruit, of course, is to support the structure. So they want to make these intricate designs with cool shapes of stacked fruit, and they can't do that if the fruit on the bottom is not going to support the fruit on top. If it's going to be crumpling, if it's going to be crashing, if it's going to break, if it's going to be oozing, like they don't want that. They want the fruit to be nice and structurally stable. The second function of the fruit is obviously to taste good. So they want people to come to the display and try the fruit and enjoy it, and then want to come back to edible arrangements for more fruit. So those are kind of their goals for us to evaluate the fruit's functions.
Our client wants their display to be stable, so the property that we decided to test for was compression. When testing for compression, it'll better help us understand how high we can build our display. Compression strength is the ability of a material to resist force before reducing in size, as opposed to tensile strength, which is the ability of a material to resist force before elongating. When testing for compression, it will also help us better understand how tightly we can pack our fruit. The other property that we are going to test for is taste. When performing a taste test, we will be able to understand how sweet and sour each fruit is and be able to tell our client which fruits they should place in groups to better complement each other.
So, the first property that we're going to be testing is compressive strength. Now, compressive strength is described as the capacity of a material to withstand compressive load. And the units of this property are in units of force, which are newtons. So compressive loads are a specific type of load that can be applied on, in this case, a biological material. Compressive loads contrast with tensile loads in that they actually tend to reduce the size of the object. So for instance, in this instance of a person who's pressing a spring together with their hands, they're compressing that spring and reducing its size, and that's a compressive load. And different biological materials, or any kind of material, respond differently to these compressive loads. So for instance, unlike the spring, which if you compress it will later kind of revert back to its original shape, here we have two materials that are very responsive to compressive loads. Even with a low compressive load, the bread experiences plastic deformation, permanent damage. It's not going to revert back to its original shape. Same with this can. The can's not going to pop back up again and be a normally sized can. Now, even though these are both responsive to compressive loads, they have a pretty low compressive strength. The can actually has a higher compressive strength, for instance, than the bread. Because the can, you need this, kind of machine mechanism to actually have enough force to get it to deform. In contrast to both of these, we have the rock, which has the highest compressive strength at all. Now, for this rock, there's a person on it, and the compressive strength, or the compressive load that's applied to the rock is so much that it's actually able to hold this person up. And the rock, it's not changing shape, it's not moving in position, it's just staying there. So the rock has a very high compressive strength. It can be under a lot of load without deformation. And that's what we're going to be kind of looking at with the fruit. We're going to be seeing how much weight they can withstand, how much compressive load they can be under without the tower crumbling.
In order to test compressive strength, we're going to be using a compressive strength testing machine that is new to the university. It is a larger version of the current apparatus that we have now in the lab, but it is designed specifically for testing compressive strength, and it performs similarly to a hydraulic press. To test your material, you need to place it on the center of the bottom plate, and you want to make sure it's centered almost perfect, otherwise your results could be skewed. And then similarly to the current apparatus, you lower the top plate down to the top of the sample, and then you are able to perform your test and obtain results. It will obtain results through the force that is exerted on the material and the amount of deformation that occurs, and through that you are able to obtain the stress and strain of the material, and putting the stress over the strain, you are able to determine Young's modulus. A material's ability to return to its original shape after deformation is known as elasticity, but once a certain threshold of force is reached, a material could reach the point of plastic deformation, in which it will not return to its original shape. This point is known as the yield point, and once it reaches this point, there is usually two characteristics of behavior that will happen. The material will either break, or it will continue to distort until it is flat. We're using this specific compression machine because we are then able to test larger samples of fruit, and with larger samples of fruit that are similar in dimension to the desired tower dimensions, we will be able to obtain results that could be similar to the desired tower.
The next property that we are going to test for is taste. And there are 5 different taste sensations that a person can perceive, and that is sweet, sour, salty, savory, and bitter. And the amount of taste buds that an individual has determines how well they are able to perceive these taste sensations. And a fun little experiment to determine how well of a taster you are is this. So if you take a hole punch size piece of your tongue and place a drop of food dye on it, your tongue will absorb the dye and the papillae, which contain your taste buds, will stay pink. You can then count them. If you have 35 or more, you are a super taster. If you have between 15 and 35, you are a normal taster. And then if you have below 15, you are called a non-taster. Taste is a sensation that an individual has when your food reacts chemically with substances in your mouth, such as saliva. Taste receptors, such as taste buds, along with your olfactory system and nerve stimulation, allows us to perceive taste, but the gustatory cortex is mostly responsible for your taste perception. In this experiment, we will be measuring taste in amps, which will be described in the next slide. In order to measure taste, we'll be using an electronic tongue, which uses chemical and electrical analysis in order to obtain a graph which determines the different tastes in the material. An electronic tongue only works if your material is in a liquid form. So for us, we will have to take our fruit and blend it up and make it into a liquid in order to use this. In the electric tongue, it uses the Cottrell equation, which will be used to make a quantitative analysis in order to put it into a graph form. In this upper right-hand corner, you can see what a probe looks like, and these probes are engineered to pick up dissolved inorganic compounds in food, and each probe is specifically designed for a certain taste, such as bitter or sour. And then in order to perform this test, you will take all of your probes and dip them into a reference solution, and then you'll dip them into your test solution. As it's dipped into a test solution, it'll send electric signals to the computer, such as how your tongue sends electric signals to your brain to tell you what you're eating and how it tastes. But instead, then it will be analyzed through the software, and then it will come up with a pattern recognition that is a unique fingerprint to the substance that you were testing. And then it will come up with a graph as seen on this left hand of the screen, and you'll be able to tell kind of if it's more salty or if it's sour or sweet, and then this will give us good intel on determining which fruits should be put in groups to complement each other.
So we'll be able to provide a really complex and comprehensive set of recommendations to edible arrangements. The first part of that is we're going to be able to give them a detailed report of exactly how much weight every type of fruit will be able to withstand, which corresponds to its compressive strength. From that information, edible arrangements will have a pretty good idea of kind of what designs or options are available to them, and from there they can kind of make their own specific designs and send them back to our lab, and we'll be able to evaluate whether they're feasible based on the data we've collected. Beyond that, going beyond kind of general recommendations, we actually will have a more specific kind of framework outline model of what we think that the tower should look like. And that is kind of a tower that's equally divided into sections, and each section has a different type of fruit, and the fruits with the highest compressive strength are at the bottom, and the fruits with the lowest compressive strength are at the top. And obviously that makes sense because the fruits that are at the top will have less weight on them, and the fruits that are at the bottom will have more weight. So that kind of design theoretical model will allow us to determine the maximum height that the display will be able to have, which is one particular recommendation we can give that will be helpful to edible arrangements. The other recommendations we have are, of course, corresponding to taste. So in addition to just recommending to edible arrangements which fruit buyer they should get each type of fruit from based on which taste we think will be the most appealing, we kind of have an arrangement of fruits that have similar compressive strengths, because that's the first way that they should organize their model tower. We will also have a recommendation as to which fruits with similar compressive strengths should be grouped together. And that corresponds with sweet fruits should be in one group, and sour fruits should generally tend to be in a different group on a different side of the tower. And that's so that if customers, participants at the New Year's Eve event want to come up with a fruit display and have a worker get down a piece of fruit for them, then they have a variety of options of different kinds of nice fruits that will appeal to their tastes all in one place. And so that we think that will create the most customer appeal. But also, we will give edible arrangements the detailed report of what the kind of taste profile is for all the different fruits, and that will allow them to use their own artistic design skills and their tastes to make the best design possible. And again, if they send us a more specific design in the future, we will be able to evaluate that, in addition to providing them with this base framework that will give them an idea of what they can accomplish.
So to conclude and review, we're working with Edible Arrangements as they want to build a fruit tower for the New Year's celebration in New York City. They want us to discover how tall they can build the tower without it collapsing and where they should position the fruit so that way the fruit flavors complement each other. The two specific properties we will be testing are compression and taste. In order to test compression, we will be using a new compression machine, and in order to test taste, we will be using an electronic tongue to test for taste qualities such as sweetness and bitterness using electrical currents. And with the data that we record, we will report that back to Edible Arrangements, and they will use this data to construct the ultimate fruit tower.
Thanks.
Stop it.
Sometimes you have to press it pretty hard.
Okay, I'm gonna stop it.
Okay.
Oh, there it stopped.
Did it?